In this video, we are going to talk about the Hesse configuration. Introduced by Colin McLaurin and studied by Otto Hesse, is a configuration of 9 points and 12 lines with 3 points per line and 4 lines through each point. It also can be realized in the complex projective plane as the set of inflection points of an elliptic curve, but it has no realization in the Euclidean plane. A Hesse configuration exists if and only if the field K contains a primitive third root of unity. For such K, the projective automorphism group PGL open and close parenthesis 3, K acts transitively on all possible Hesse configurations. Automorphism group of the Hesse configuration has 216 order, also known as the Hessian group. So here is an example of a Hesse configuration. A Hesse configuration with 4 of its lines, the 4 broken diagonals of the 3 by 3 array of points drawn as curves. So here you can see that 4 curve line. And according to the description of the Hesse configuration, it has 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it has 12 lines. So you can see that 12 lines here. This is the first one, this line that goes through all the way here, 1, this line here, 2, this third line, 3, and this fourth line, 4, and the rest of the 8 is here, 1, 2, 3, 4, 5, 6, 7, and 8. So all in all, there are 12 lines, and with 3 points per line, you can see that, let's get this line here, this curved line. This is the first line, 1. You can see this 1 point, second point, and the third point that goes all the way here. Another line, this line here, 1, 2, and it goes all the way here. So this is the third point. And let's get this straight line here that has these 3 points. This line, 3 points. And 4 lines goes through each point. So let's get this point here. As you can see, this is the first line. This is the second line. This is the third line. And the fourth line here. So another, we go to the middle point. You can see that this is the first line, the second line, the third line, and the fourth line. So all of the points has 4 lines going through it. Lastly, Hesse configurations has related configurations. By removing any one point and its 4 incident lines from the Hesse configuration produces another configuration of the type 8 sub 3, 8 sub 3, namely the Mobius-Cantor configuration. The 12 lines may be grouped into 4 triples of parallel, non-intersecting lines, removing from the Hesse configuration the 3 lines belonging to a single triple produces a configuration of type 9393 or 9 sub 3, 9 sub 3, namely the Pappus configuration. And it may in turn be augmented by adding 4 points, 1 for each triple of non-intersecting lines, and 1 line containing the 4 new points to form a 13 sub 4, 13 sub 4 configuration. So to explain that first related configuration, when you remove 1 point, any 1 point, or let's go here, any 1 point, and its 4 incident lines, you can form a Mobius-Cantor configuration. So let's see, if we remove this point here, this line, we will form a Mobius-Cantor configuration. So we have 1, 2, 3, 4, 5, 6, 7, 8 points. And if we remove these 4 lines, we also have 8 lines. So it is true that we can form the Mobius-Cantor configuration of 8 sub 3, 8 sub 3.